Hello students, we have a question. 2-point charges Q1 as under root 10 microcoulomb and Q2 negative of 25 microcoulomb are placed on x-axis at x is equal to 1 meter and x is equal to 4 meter respectively. Now the electric field on y-axis at a point y is equal to 3 meter we need to calculate. So in this we have a situation that we have two axes. This is y-axis we have and this is x-axis we have, and in these two axes we have the two different charges, that is Q1 at 1 meter from the origin, and we have another charge which is negative in nature minus Q2 which is 4 meter from the origin, and we need to calculate the electric field at a point which is 3 meter on y-axis. So this is a situation we have. Suppose this is a point P. So due to this charge Q at point P, we will experience an electric field, and this electric field will be in this direction. We name it as E1. This is the vectorial direction we have for E1. Now if we consider that it is making an angle theta 1, so we will have the two components of this E1 as E1 cos theta 1 minus I cap, because it is negative to I cap. Now if we talk about this component, so this will be E1 sin theta 1 plus j cap. Now if we talk about the next charge, so we have Q2, and this Q2 negative will make an experience at point P of the electric field as this way. This is we have E2 vectorially, so it will have two components of it in these two directions. Now if this is theta 2, so this will be alternative angle as they are parallel lines, so it will be E2 cos theta 2 positive I cap. Now if we talk about this component, it will be E2 sin theta 2, and this will be negative j cap. So this is what we have the situation. So first of all we will find the values as per the, first of all we will find the magnitude, and that magnitude we can see that E1 will be, E1 in magnitude will be 1 upon 4 pi epsilon naught Q1 upon R1 square. Now where is R1? This is what we have, R1, which is equal to under root of 3 square plus 1 square, that is under root 10. If we talk about R2 here, so R2 will be under root of, taking the triangle of theta 2, the big triangle, we have 3 meter and 4 meter, so it will be 3 square plus 4 square, which will result in 25, or we can say 5 meter. So this is what we have, R1 and R2, the position vectors. So on putting the values, we have the value 9 into 10 to the power 9 as of 1 upon 4 pi epsilon naught into Q1 we have under root 10 into micro coulomb divided by R square we have under root 10 whole square. So this is what we have, and on solving we are getting 9 into 10 to the power 9 minus 6 into under root 10 divided by 10. So this is what we have the value, and this is the value of E1 in only magnitude. If we talk about full vector of E1, so it will be the magnitude and the multiplication of magnitude with the two components of unit vector. So these two components we have sine theta 1 j cap plus cos theta 1 minus I cap. We can see the situation in the diagram. We are talking about this and this unit vectors. So this is the situation we have. So again we are writing E1 is equal to 9 into 10 to the power 2, and this 10 will be cancelled and we will get under root 10 here, and the value inside we have, in place of sine theta 1 and cos theta 2 we, and this 3, this is under root 10 and this is 1. So the sine component we will have 3 divided by under root 10 j cap, and this is negative, so I write negative here, and it will be 1 upon under root 10 I cap. So this is what we have E1 value. Similarly, we will find out the value for the E2. So E2 in magnitude will be equal to, we can see that E2 value is 1 upon 4 pi epsilon naught. We will add 1 upon 4 pi epsilon naught into Q2 upon R2 square. Negative just represents the direction. So we have introduced in the coordinate system. So we are not taking here. The value is 9 into 10 to the power 9 into, and the value we have 25 microcoulomb. So it is 25 into 10 to the power minus 6 divided by R2 square we have. So we directly write 25 here, 5 square. So 25 is cancelled out, and 9 and minus 6 results in 9 into 10 to the power 3. So we have the magnitude of E2 to be equals to 9 into 10 to the power 3. So this is what we have, volt per meter. The magnitude, volt per meter. Now if we talk about its full vector, so it will be E2 multiplying the unit vectors with this. So we have, now we are taking another triangle, and this triangle is having angle theta 2. The given values are 3 meter, this is 4 meter, and this we have 5. So we write here the value as, term will be cos theta 2 I cap. As we can see, this is cos theta 2 I cap, and this is minus j cap with this value. So we write these two values as cos theta 2 I cap minus sin theta 2 j cap. On putting the value, we are getting 9 into 10 to the power 3, and we have inside value as, we talk about cos theta 2, so it will be 4 divided by 5, and if we talk about sin j cap, sin theta 2, so it will be 3 divided by 5. So, and the unit vectors are also there, j cap, I cap and j cap. So we have these two values. If we needed to find out the resultant, which is ER, so we need to add these two vectors as E1 plus E2, the full vectors. So the expression we already have, and for adding we need to add up. For adding we make it more simpler, and on adding we are getting the final expression, that is 9 into 10 to the power 2 taking common, and the addition and subtraction after we are getting this expression. Now on further solving we are getting this 9 into 10 to the power 2, and in bracket we have 7 I cap minus 3 j cap. Now we are getting this as 10 to the power 2, and multiplying 9 we are getting this much. So this is what the final expression we are getting for the resultant electric field experienced at point P. So option A is the correct answer of this problem. Thank you.
Three charges plus q, small q and plus q are placed respectively at a distance 0, d by 2 and d from the origin on the x-axis. If the net force experienced by plus q placed at x is equal to 0 is 0, then find the value of q. According to the question, the diagram, this is x-axis, this is x is equal to 0, this is x is equal to d by 2, this is x is equal to d. Here plus q is placed, here small q is placed, and here also plus q is placed. According to the question, the net force experienced by this plus q is equal to 0. Then we have to find the value of small q. In the electrostatics, the force applied by any charge on another charge is equal to k, q1, q2 upon r square, where r square is the distance. Now, the force on plus q due to another plus q is equal to k, q upon r square, here r is equal to d. Then force on plus q due to small q is equal to k, q upon d divided by 2 whole square. So the net force on plus q, net force is equal to k, q square upon d square plus k, q upon d upon 2 whole square. This should be equal to 0. So we get k, q square is equal to k, q small q into 4. So we get q is equal to minus capital Q by 4 coulombs. Therefore the value of small q should be minus q by 4 coulombs.